Hi, Jessica here, and I'm with PRT Guru, Peter Muller, and today we're going to talk about three different roles for PRT. And Peter, what do you mean by this? I mean, a bus is a bus, a train is a train. I mean, how can PRT have different roles to play?
Well, Jessica, a bus is a bus and a train is a train, sure, but buses themselves sometimes play different roles. You've got like city buses that run around the city, and you've got shuttle buses at an airport. And in a similar way, PRT can play different roles in different places. So the different types of roles we're going to talk about are campus-type applications, where it's a smaller system. And then we're going to talk about collector distributor, where PRT is feeding some other type of transit, like rail. Mm-hmm. And finally, we're going to talk about citywide applications, where it's going throughout the whole city. So to start off with, on campus-type applications, what we've got here is kind of a high trip demand, lots of people wanting to move around a small area. So examples are, for example, the PRT system at Morgantown University in West Virginia. Obviously, that's the university campus. The students have to move between classes, and the PRT system helps them to do that. Another PRT example is the one that's going in the city of Masdar in the United Arab Emirates.
Well, I mean, Masdar is a city, not really a campus. Like how?
Well, yeah, that's true. What we have in Masdar is it's really a small city, and it's a small city confined to a fairly small area. The population, I believe, is going to be in the order of 50,000, expanding to maybe 100,000 when all the workers come in to commute to work.
So it's related to a campus like...
It really is kind of like a big campus or a very small city. Another application is the Heathrow application at Heathrow Airport. And airports are kind of like campuses. There are small areas with lots of people moving around them. When you have a PRT system in a campus-like application, you don't need high speed because you're not going very far, and therefore you also don't need much range. This favors PRT systems that are battery-powered because they tend to be a little less expensive than the ones that pick up power from a third rail. It also means that the PRT systems that are coming out now are suited to these kind of systems, these kind of applications, because they have headways of around about 3 seconds, and with the 3-second headway, they can meet brick wall requirements.
Okay, and now I don't know if this has anything to do with me being a blonde or what, but you're going to have to explain 3-second headway and brick wall requirements, because I don't really know what that means.
Well, when these systems run at about 30 miles an hour or less, and there's 3 seconds between them, which is what the 3-second headway is, that means that they can stop before hitting the vehicle in front of them if the vehicle in front of them had to magically, instantaneously turn into a brick wall, which is a requirement that we have for trains, which may or may not be applicable to PRT, but even if it is applicable to PRT, these systems can do that at 3 seconds between them. Another campus-type application is one that we're studying for the Army. It's on an Army post just down the road here in Colorado Springs called Fort Carson, and here we're looking at a system that would have about 35 stations, 22 miles of guideway, and some 600 or 700 T-pods. So that, an Army post is another campus-type application. I'm going to talk a little bit about collector distributor for rail. One of the problems we have with rail, and especially high-speed rail, which President Obama is promoting, is that the more stations you add, the slower it becomes, because every time you have to stop at a station, you lose speed. So this is a problem with conventional rail.
I mean, can't you just have fewer stations and then just have a different type of transit? bring them to that?
Like a bus system?
Yeah.
Yeah, the problem with bringing people to rail on a bus is that people don't like to transfer between modes of transportation where they're supposedly running on a schedule, and so if the bus is coming every 20 minutes and the train is coming every 20 minutes, you could have to wait 40 minutes if you miss a connection or something. These things don't work very well together. However, if you bring people to rail with a PRT system where you never have to wait more than a minute, it makes a much more efficient collector distributor system, and is one that people may end up really using. So this is kind of how it could look. Where you have your rail line going from A to B, and maybe not going exactly straight there, but if you replaced the rail with a system that was a combination of rail and PRT, you could remove some of the stations on the inside of the system, and maybe also remove the stations towards the end of the system and replace those with PRT collector distributors. Now, rail is typically much more expensive than PRT. So when you remove those stations, you're saving cost to the rail system. You're also allowing the rail system to run faster. When you replace that with a PRT collector distributor system, you add back most of the cost of those stations, probably all of the cost, maybe a little more, maybe a little less. So what you end up with is a system that costs around about the same, has a much greater service area, and you actually reduce the time from one end of the system to the other end, because even though you're having to use some of it on a relatively low PRT system, you have very little waiting time in the PRT system, and then the rail system runs a lot faster. So it turns out you've got a much better combined system for maybe about the same cost. Now, when we get into citywide transportation and we're taking PRT all the way across the city, we're going to have to operate at speeds probably in excess of 40 miles an hour and headways down around 1 second. Both of those are beyond the capability of PRT systems that are coming out now, but they're expected to be capable of that quite soon.
And now I understand the need for higher speeds getting across town, because obviously, the faster you go, the faster you get there. But why would you need lower headways for that?
Yeah, actually, the reason you need lower headways is because headways define capacity. So if you have headways down around 1 second compared to headways around 3 seconds, you actually can get 3 times as many people through the system. And when you're doing citywide transportation, you're going to need a lot of capacity in these systems. So you're going to need what a lot of people call high capacity PRT, and that means lower headways. So here's a graph that shows the results of studies that have been done around the world. Some of these are in the US, as you can see, but they show how transit systems attract people currently without PRT and how they would attract people with PRT. As you can see, in every instance, the number of people that would use transit, if you added PRT into the mix, doubles. In some cases, it way more than doubles. So PRT is going to attract, on a citywide kind of system, PRT is going to attract a lot of people to transit. And since PRT is a very energy efficient form of transit, this is going to be a really good thing.
All right, well, that was very informative. Thank you. Next time, we'll talk about just some hurdles that PRT has had to overcome. So thanks for joining us today, and you can always find out more on Peter's website at www.prtconsulting.com, and he's also on Twitter under the name PRT Guru. So we'll see you next time.
Salam.